Hi, so I've wanted to show you how to put in a solar system. This is a barn. I haven't quite finished painting, and if we look around here, let me flip the camera around. How do you flip the camera around? Around here is the where the magic happens. These are the solar panels. I've got 4 of them off Amazon, and I'll see if I can reach up up there. They look like that. Each one's maximum 120 watts, so that's 500 watts in total up there. Now I've wired them in series, so it comes out, connects to the next one, positive to the negative, connects to the next one, positive to negative, and then the final cable goes all the way back inside. I'll show you. So here we are inside. There's a fridge running. What we've got is here are the wires coming inside. As I said, they've been put in series, so each one's about 20 volts. Because they're in series, it means we're going to be adding the voltage together. So we should have around about 88 volts. So if we look here, yeah, this is the voltage from the panels. Where's my finger? There. That's the voltage from the panels. 88 volts. Now what I've done is I've also put in a switch from the panels, big switch, because it's important that you don't have the panels on and the batteries off with the charge controller. You can have the batteries on but the panels off, but not the other way around. Okay, so let's look at all the different components. Everything's off Amazon, and I'll give you the prices in a second. But that is what's known as an MPPT charge controller. It's by a company called ePiva, and it's got a positive and negative from the panels, a positive and negative to the battery charger, and a positive and negative that I couldn't work out what it was for quite a while. It's called the load. You can put up to 20 amps on this 20 amp model onto that load, but your inverter shouldn't go here. It should go on the batteries. Let's have a look at the inverter. Here's the inverter. So it takes a 12 volt input from the batteries, produces up to 1500 watts at 240 volts. And you can see that it is connected straight to the first battery in the battery bank. Now this battery bank is going to grow. At the moment it just grabbed some old car batteries. Down here is another little circuit breaker and fuse. Now that's rated at 2 times the current of the system, which is a 20 amp charge controller. And I'll explain how all this is wired up in a second. Came with a sort of extra, which I think normally is supposed to go outside, but I've got it next door here. So it's got a grey cable, data cable coming out, and it connects to this, and this thing shows you the whole story. So you've got the voltage of the panels here, and the current 1 amp. Here's the battery with a happy face. It's putting 14.1 volts across the batteries and delivering just under 2 amps at the moment. The load is powering that fridge, which you can hear. It's obviously a 4.5 amp fridge, which is more than I was expecting. But anyway, that's what that display does. The inverter as well also has a data cable and a kind of a remote control, so we can turn the inverter off here and we can see the state of the battery charge, which is currently green. And then I've plugged in an adapter, and so now I've got my power. So it all works nicely. So let me explain a few other things. So as I mentioned, the panels I've put in series, so that means the voltages get added up and the current stays the same. I've done the same with I've done it differently with the batteries. The batteries are in parallel, so the voltage stays at 14 volts or 12 to 14 volts, but the current increases as you add each battery. So all your kit is going to have ratings which it can't exceed. So in the case of the charge controller, that can't exceed 100 volts. So now I can't add another panel now, because that would put me up to about 110 volts. So I can't add another panel or I'll exceed the voltage. But I could add another more panels and put them in parallel. And then I would, the voltage wouldn't go up, but the power would increase and the current. So the batteries, as I said, are in parallel, and what that means is that each battery you add in a chain, you just add new connectors, positive to positive and negative to negative, and it's as simple as that. I've actually ordered, I'm going to get rid of these. I've ordered some leisure batteries. These are car batteries. And the leisure batteries apparently are better at discharging and recharging all the time. And I've got 3 of those coming, and that'll give me a decent amount of storage. Other minor details, I actually haven't connected it, but there is an earth terminal on this charge controller. This is what's called a common negative controller, so that can be connected to all the negatives in the whole system can be connected together, and then you can put a wire to the ground anywhere you like in that chain. The other thing is this switch. It's just a switch, so I can turn the panels off by rotating that. It's a nice big 1000 amp switch, and you'll see here, there we go, the panel sets gone to nighttime, 0 volts. So now the battery that my fridge is producing is drawing 4.1 amps, so the battery is losing 4.1 amps here. So let's switch that panels back on, click, and we'll see that, there we go, there's the array come on, straight up to about 90 volts, and the current will start showing, I hope, there we go, 1 amp. And eventually that figure will go positive, there we go. So it's actually producing about 6 or 7 amps, 2 go to the battery and 4 go to the load. This switch, I don't really know enough about electrics to understand whether I need to have both positive and negative cables going through that switch, or just one. But at the moment I've just got the one switch, the one side of the solar panel array cable going through that.